Start. Thank you for being up this early and or this late, Dr. McGowan.
More like that.
Either one's fine, yeah.
Okay, that kind of covers.
Yeah.
Your
Yeah, go ahead, yeah.
Put the lights on or off?
I'm gonna leave them on because it's easier to see the board on the video with them on.
Okay, gotcha.
So, do you close the door? So hi, Paul. My brother's watching.
Okay.
You close the door.
I've got 1 minute after.
Oh yeah. So you
You
go.
ready?
Yeah, go close the door, please.
Okay.
My allergies are loud.
All right. Okay, thank you everybody for coming today to Miles's presentation. And she got her undergraduate degree in emergency management, and then she has come over and spent 2 years with us in the geosciences, and she's graduate. Hopefully she'll graduate in May. Looks like she will. And she's going to talk about blue tarps, drones, remote sensing, different algorithms for identifying blue tarps, and she has at the end a surprise like James had yesterday, a potential paradigm shift. So go ahead.
Thank you everyone for coming. So yes, like Dr. C has introduced, I'm Madeline Miles, and this is my master's thesis defense. We are going to be analyzing the effect of remote sensing techniques, blue tarpaulin inspection, or just blue tarp for short. So how did we get here? Why blue tarps? So my hometown, Newton, Georgia, March of last year was hit by an EF4 tornado. My parents kept sending me all these pictures, and it was all from ground level because they don't know how to fly a drone or open a PDF. But they kept sending me all these pictures of like destroyed houses, branches down, and I was like, oh wow, that's terrible. And then when I finally got out there and I did fly my drone, something fascinated me, and it was I looked down from my aerial point of view, and all I could see was blue tarps, and I thought that was awesome. I was like, this is what's standing out. So 3 months later, again, when I finally got out there, I took this video, and this is what started my thesis. It was, there's blue tarps. Okay, well, how is being analyzed? They stand out so well, there must be a great remote sensing opportunity here. And also, who's putting up those tarps? Is it just the homeowners? What's going on here? I want to know. I want to merge my emergency management background and my GIS background. So that led me to discovering Operation Blue Roof, which is through the U.S. Army Corps of Engineers as well as FEMA. So they work together, and they will go out and provide homeowners who have a roof structure that is 50% lesser damage, and they'll go out and install a blue tarp, or as they like to say it, a fiber reinforced sheeting, which is a blue tarp, for free to the homeowners. And once that is done, that structure is now cleared for the homeowners to return, so they can live there again. And I thought this was really interesting because that means that that home is now livable again. That is someone in that area who still needs recovery help. They haven't left, they're still here. So, as Dr. Morgan likes to always ask, why is this important? Why does it matter? Well, it matters because we can find different remote sensing techniques to track these blue roofs. I want to pull out the blue roofs, these tarps, on the structures and look at them away from all the other data. So, for example, here we see 2 homes that have been just really hit by this tornado. This one has had a tree, looks like it crashed all the way over it, and we kind of assume, oh, no one's here. Whereas this one is under repair, so it was hit by the same tornado, but there's a blue tarp there. I know there's people there who, again, still need help with recovery, which is a very important phase of the emergency management cycle. So I want to find out how do we help them recover? How do resources use, how are we applying our resources in recovery? So that led me to come up with 3 methods, use one software for them all. So my 3 methods are image segmentation, machine learning, and supervised classification. My one software is ArcGIS Pro. That's how all of my methods are processed. I wanted to keep it simple and accessible. I want something that could be repeated by other people. So my first step was obviously to go out and collect my data. I used a DJI Phantom 4 with an RGB sensor. I used RGB because it's accessible, it's open to everyone, and it's not an expensive sensor. Pretty much anyone can go out and buy an RGB sensor that's amounted to a DJI Phantom 4. Phantom 4 is like DJI's like premier drone. When you think of drones, you probably think of a drone like this. So again, I wanted to make sure this was something that was accessible to pretty much anyone. Anyone can repeat this. Any EMA can go out and buy this drone and fly it. It's very simple. I use Pix4D Capture as a software to map out the area that I am flying. Again, that was just to keep it standardized, so I knew exactly the area that I flew. I used an above ground level, or AGL, 150 feet. So again, this is 3 months later that I went out and collected. So there's no emergency aerial operations going on at this point. So I don't have to worry about flying in a no-fly zone or anything. And my overlap was 70%, and my side lap was 30%. This is at minimum. This is so that my orthomosaic process can be as easy as possible. So to pre-process my data, I used another Esri product, Drone to Map. Again, this is Esri's products, especially the Art Pro and the Drone to Map. If you can use Microsoft Word, you can use these softwares. They use a very simple ribbon at the top, which is like where you go click everything, and that's how you process your data. It's very simple. Again, if you can use Microsoft Word, if you can use Google, you can use this tool. It's very easy to use. So my resolution is 1.2 centimeters per pixel, which is incredibly good. Drones are amazing. It's why I love them so much. Again, accessibility and repeatability is important. So I can see water hoses. I can see a person laying on their roof, hopefully just taking a nap in these pictures. And out of my 219 images, 213 were able to be orthomosaicked. The errors that occurred were holes, literal holes in the orthomosaic, which was likely due to the fact that I flew on a slightly more windy day than expected. So the drone was unable to correct for that tilt there was in the image. So as we can see in these two, there are holes. In this one, it just stitched it a little bit strangely. That's not a major problem because there's not a whole lot of blue tarps on these roofs going on. So I wasn't incredibly worried about that, and it's pretty common as far as drone imagery research goes. So my first method, segmentation. So this is going to separate the image into different parts, and then we're going to classify it on those pixels in that part. So in this example, we can see after they've separated, they've said all these pixels here are cars, 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 more cars, and they've gone with the road. So that's how segmentation works as an overview. So again, you give it comparable values and breaking it down into classes, which we're going to see a lot of. So when I did this, here are my 6 classes. The tan is the barren, which shows up a lot. That's fine. The important part is these blue right here. So those are my blue tarps. So over here, you can see some examples of some falsely classified areas on blue tarp. This one is like a roof of a gazebo, probably someone's like pool house. This just has a shadow, and segmentation would, hey, that's a blue roof. And I had to later tell it, no, that's not a blue roof, don't worry. This one is potted plants. I don't know why segmentation thought it was a blue tarp. Even going into Google Street View, it's not blue at all. Successfully, it did find these two as blue tarps. You can tell the blue tarps, looking at obviously their shape. They are very rectangular and square, so this is very clearly a blue tarp. So as far as numbers goes, 0.82% of all the pixels in my orthomosaic are blue tarps. Originally, it thought there were about 2,000, but a bunch of those had to be removed because they were not actual blue tarps, which visually looks like this. So here, for example, is a pool. It's not a blue tarp on a roof, so I had to go remove that. And this house over here is another problem area. It just has a white roof, and it thought it was a blue tarp, and the reflectance value it thought was similar enough to segment at its one. So my next method was machine learning, which is very new and very exciting and really amazing technology that was very interesting to get into. So machine learning works like segmentation in that we're going to go through and classify it based on the pixels that we're seeing. So here's my breakdown. So I prepared my training data. So we had to locate objects using the deep learning tab, which is again it's a few clicks on ArcGIS Pro. So far, so easy. Then I trained my model, which again works a lot like generic classification. So I go through and I say, hey, this is a group of blue tarps. This is grass. This is my shrubland. This is the roof of a house. It's developed. And then I want you to go use that model. And based off that model, I want you to classify or detect. And so to do that, I had to download a deep learning library, which was a little bit scary, I'm not gonna lie, because I had to go outside of R because I kept getting errors. And I was like, what does this one mean? I had to go track that one down. So Google is my friend. So in the end, I went with PyTorch because that's the one that ArcGIS, that Esri recommends. This was the one that they said, hey, go use this one. This one's a good one. So after training my data using the deep learning library, I was able to get a loss graph, which is a little bit confusing, but basically it wants to find a fit between the underfit and the overfit model. So it's looking at the train versus validation here. And here we can see it processed a lot, and then it kept going, which isn't terrible. It just uses up computing power. So it kept going. It was like, okay, we'll keep going. And the next time I did it, I was like, okay, you can stop a little bit sooner. It's okay. So we see the next one in a little bit sooner. And these graphs are a little bit confusing, especially if you've never heard of a loss graph. But basically, it's saying these are good when we look at our trained and our validation lines. When they come together, that's what we want to see. So what that gave me was my ground truth and predictions from the mouth. So I gave it this picture, and it said, okay, this is cultivated or planted, just grasses. So when you go out and mow your lawn, that type of grass, that's your cultivated area, or a garden. But excitingly, I gave it had this picture, and went, okay, that's a blue tarp. I was like, yes, that's awesome. That is, in fact, a blue tarp. And it did really well with developed, especially. It really liked the developed, which I was interested in, because you can see here it's actually a blue hose, but it went, no, this whole area can be classified as developed, even if there's a blue hose there, which for some reason it really liked to say that blue hoses were blue tarps. So after that, it started to go downhill. It decided that it didn't want to do anything. It didn't want to run. It didn't want to classify. It never gave me a meaningful result that I could say, hey, here's my map of my classified objects from machine learning. So unfortunately, didn't work. Error. But that's fine, because I went to my next method, which is supervised classification, which if you've done any GIS work before, this one should be familiar. This one is the classic one, an oldie but a goldie. So we went through, and I said, hey, here's this class. Here are my classes. I want this one to be my blue tarps. I want this one to be my developed area, and so on. And this one gave me pretty good results. I liked this one. Here's what it looked like as a whole, about halfway through the same area. It gave me a lot more shrubland because it's doing a lot more. It's supervised. It's not unsupervised. It knows that, hey, you gave me this class. It's going to be this one. And it said this one was originally a blue tarp. But I can very clearly look at that and say, hey, that's not a blue tarp. Blue tarps don't look like that. They're not these like little dotted areas. They want to look like this big area. And this one, which should look familiar because it's the same one that segmentation said, hey, this is in fact blue tarp. I was like, that's awesome. These two methods gave me, in fact, really similar results, as these numbers should look similar. The 0.77% of all my pixels in my supervised classification are blue tarps, after correction, that is. Before removing, it said about 1,600 were, but again, I had to go through and remove that errors, such as pools and trash cans, which we'll talk about in a moment. And this is what it looks like. So again, looking at that pool, we see it's removed later. And again, this house had a lot less of a problem, saying that white roof was a blue tarp, as we can see in the correction. Less of it had to be removed later. So it showed me a slightly different, but similar result. So when it came to comparing this, I want to do an accuracy assessment. So the way the accuracy assessments work is they give you a kappa value. So we see a lot of numbers over here. Basically, we want our kappa value to be 1 or 0. So a 1 value will tell me that, hey, this is not accurate at all. This is not even the same landmass or something. A 1 value will tell me, hey, this is really accurate. This is great. So georeferencing all 3 of my images or all 2 of my images against my original orthomosaic, it said, hey, this is accurate. So I was like, oh, that's cool. The images are talking together. They know what it is, and it's saying this is in fact accurate. So let's talk about some of my quick errors. Blue things that maybe want to bang my head against the keyboard. This pool and all this lovely blue pool furniture. Every time, every classification was like, no, this is a blue tarp, but it never is. This is a children's play structure. like a little fort or something. It also pretty much every time got caught up on the blue, being a blue tarp. This is a hose. Water hoses got me a lot. And not necessarily only blue cars, but car windshields, for some reason, always wanted to tell me it was a blue tarp. And then trampolines. And then Noonan, we have these lovely bright blue trash cans, which their reflectance value is it pretty much is exactly the same as the reflectance value for a blue tarp. So every method said, hey, this is a blue tarp. And every time I had to say, no, it's still not a blue tarp. So I'm pretty sure trash cans made up most of my errors, as there are about 91 land parcels, so that's roughly 91 boundary areas, so 91 homes in little, that have blue trash cans. So about 91 times I had to go through and remove blue trash cans. So look at my results of my supervised classification, looking at my results, from my supervised classification. Again, it told me about 1,000 or blue pixels or blue tarps on roofs. About 1,600 had to be removed, or it told me that originally, and then 390 had to be removed. Now compared to my image segmentation, again, a very similar number of blue tarps. Originally had more classified as blue tarps, and I then, as a result, had to remove more that were not blue tarps. That's a lot of numbers, but what does that mean? About 800 is about 800 pixel difference, which is tiny. Again, with a resolution of 1.21 centimeters per pixel, that's not a whole lot of stuff. Or it's about a 73.841 pixel difference, which is tiny. There's not much of a difference between my supervised classification and my image segmentation results. So, well, which process is easier to repeat? Which process should I recommend to EMAs and non-government organizations or NGOs? Which process should I tell them, hey, this is what you want to do when you're looking for blue tarps on roofs? So I have my segmentation, I have my deep learning, and my classifications. Well, pretty simple answer. Supervised classification. Why? Well, it's less steps, it's a faster process. In general, it's more accurate, and also it's more widely recognized. Again, if you talk to someone about remote sensing, they're going to know where supervised classification is. If you go to an EMA who only has one GIS person, they're likely going to know how to repeat a supervised classification. And also, compared to my deep learning, it actually worked. So, when I look at my breakdown of land parcel overlay with my supervised classification, I found that about 25 structures in land parcels. And land parcel is just your boundary lines between houses. I looked at only one's land parcels with a structure on them, because some people have yards. They're different land parcels, but it's just a yard or something in there. About 25 of them had a structure. So when overlaid, this is what it looks like. So all the red zones we see here are structures that have a blue tarp on their roof, which looks like a lot, but when it's actually broken down by land parcel number, about 73% did not have a blue tarp on their structure. So that's where I use my supervised classification to overlay it against. So, what next? Well, I have all this data, I have all these results. How do I apply it? CTARP, Colored Tarpaulin Analysis Recognition Procedure. And it is colored tarpaulin and not just blue tarpaulin. And I'll get to that in just a moment. So, this is CTARP. This is a procedure that I came up with and I followed along. It starts with everything from your data collection to your orthomosaicing to your classification, supervised that is, all the way to removing the blue tarps and then editing them to remove things such as pools and blue trash cans. So this is my procedure I came up with. 6 steps, here's one optional. So my CTARP results look a lot like this. So I know that these are all blue tarps. So these are structures that have been damaged, but people have not given up on. There's still people here that need help in the recovery phase of emergency management. So looking towards the future, out of my 100,000 unique colors of my entire orthomosaic, this is what the average color looks like. So we see a lot of earthy tones. We see browns, greens, some grays, which are typically your developed areas. This is what my pool and trash bin average color, pixel color looks like. And this is what the average blue tarp color looks like. Again, they're very similar. So I asked myself, what do I not see? What color is not commonly found on homes or in nature? Well, not pink. So I was like, well, why don't we use hot pink tarps? Why, you might ask? Well, they're easily identifiable. Anything with their RGB sensor can pick up a hot pink tarp. It doesn't have to be hot pink, but hot pink's fun. And so by satellite, and UAV, and RS, and visually, remote sensing RS, you're going to be able to find these hot pink tarps. So if we supply people with these ones instead of the standard blue ones, they're going to stand out a lot better against everything else. It also doesn't conflict with typical caution color or hazard coding, such as like biohazard stuff is often colored red. It's dangerous. Whereas like things like caution cones and caution tape is orange and yellow. So I didn't want to conflict with that either. So pink. Also, this is very simple technology to put in place. It's not reinventing the wheel. It's just changing the color of a tarp. It's going to contrast dramatically with a roof. If you put a hot pink tarp pretty much anywhere, people are going to take notice. Also, it's a little bit cute. So that is why I suggest hot pink tarps instead of blue for using C tarp and not B tarp. Because B tarp would be blue tarps. So I want to say thank you to the JSU Chemistry and Geosciences, because I did use their drone and their technology and their supercomputer. And also to my committee, thank y'all for being here and on Teams. And also, is there any questions?
First of all, thank you.
Yeah, thank
you. And I did have a couple of questions, if I may, really quickly.
Yes, sir.
But let me preface that by saying I love the pink tarp idea,
I'm
or
glad.
maybe even a blaze orange color,
Those would also work.
which might work. But back to the actual process itself,
Yes, sir.
is there not a way to do one of two things, or maybe both of those things? Write an algorithm that would pick up on straight edges, which would help identify blue tarps better than swimming pools, maybe, unless it's a square swimming pool.
Yeah, well, there are a lot of square swimming pools. To write a procedure like that, that would take more time. And also, I want this to be something that can be thrown out in a pamphlet to any EMA, anyone in emergency management, and I can give them, hey, if you have ArcGIS Pro, here's what you can do.
Right.
Here is a simple procedure. It's 6 steps. It's not very complicated either.
Right.
It's something that anyone who knows how to open ArcGIS Pro can follow. So I hope that answers your
Well, I was
question.
suggesting you create it and make it part of the package that you're going to throw out.
I could do that, yeah.
As part of the remote sensing.
Yeah.
Another possibility is the exclude areas of minimum size, like a trash can.
Yes, so I ran into a slight problem with that, in that some people have gone through and they put, it bothered me so much, I'm sure there's a great way to see it on the PowerPoint, but there's little squares that are about actually the same size as a trash can lid. There's one house in particular that is covered in them. I don't know why they didn't just use a big tarp, but they've gone through and they're, again, they're about the same size as a trash can lid, of square blue tarps.
Well, that'd be a problem.
So yeah, that was something that I was like, oh, I can just limit by tell it to only include pixels of a certain size or object.
Maybe they put them on their dog houses or something.
No, it was on the roof, but yeah,
It was on the little small patches.
yeah,
Okay.
there was about I think there were 8 of them.
Okay. Maybe missing a tile.
Any other questions?
This would be tricky because of the angle of view to be directly overhead.
Yeah, it
The
was
trash can.
oblique, yeah. So yeah,
But can you do a dimensional component and image classification?
Dr. Seer. Dimensional view. I could, I guess,
Like
yes,
to
tell it to
exclude-
exclude of a certain size. Yes, but again, I didn't want to do that because that would be excluding some houses that use small tarps, but a lot of them. But yes, it is possible, yes.
Maybe we're testing to see which one would be more, how much you would lose.
Yeah.
And much it would introduce in that for smaller.
Dr. McGowan have a question?
You have a question, Dr. McGowan?
Not really a question. I was kind of thinking about why they would have the small tarps, like you were saying, like kind of got the small squares. I think it might be, that could be a situation where people did it themselves.
Mm-hmm.
Because normally when you want to put a tarp over a roof, you want to make it as large as possible to cover
Yes.
up and make sure it flows properly. So it could just be someone who did it themselves and didn't really know how to do it. And then
Yeah, or only small tarps were available.
That's all I had.
Yeah. Yeah, I also saw that a lot of people use small tarps. Their chimney had been destroyed. It's about the same area as a chimney as well. I saw that on a few different houses. So that was another reason to not exclude based on size. Any other questions? Are there any questions on the live stream? Oh, sorry, just like this one.
So ArcGIS Pro could be expensive for ESM EMAs.
Yes.
Sometimes they're like short staff and they don't have that much budget. So do you have plan to suggest also like open source software?
Yeah, I think that this process could be definitely redone in like a QGIS or a GraphGIS, or if they have access to Arc Online, you can run the same tools typically. So I think this could definitely be transplantable to other programs and not just limited to ArcGIS Pro. Hope that answers your question.
Yeah. thank you.
Okay. Any questions in the live stream, James?
Oh, that's you.
Oh, yeah, that's me.
You're logged in.
Yeah.
No other questions?
Other
I
questions?
do have one other question to follow up on this, so that we have all this together, we put the information out there,
Yes, sir.
and it's the next question that I asked that you forgot about. So what?
So what?
So what?
So what? Oh, well, so what? Well,
What do we do with it now that we have it and we can identify all the blue tarps? How do we use
we
it?
get it to EMAs and NGOs and people who are trying to help with the recovery process. That's my next step, is to
Okay,
get it out there. Information's no good if I'm keeping it all to myself. I want to share. So again, that was part of the process, is I want this to be something useful, something that can help others. It's not just for, oh, it's fun because I can do it. No, I want other people to use this and improve upon it if they want.
yeah, I was thinking about actually taking the information, because you said it was 50% or less damage.
Yes, 50% less damage is when they will put a blue tarp on with Operation Blue.
And so if it's possible to say 50%, or let's just say 25% on average, I don't know, I'm making up a number. And we know the average value of properties in these particular areas. We could even do a value damage assessment
Yes.
based on some dollar figure, with obviously you gotta have a little leeway. But
Yeah. I try not to get too much into like private people's insurance or looking at home values, but all that data is available from the Noonan GIS data, which is where I got my land parcel boundaries from. But that would be very interesting to actually look at how damaged the money-wise was later.
Yeah, to go back to the campus when the tornado hit here, a couple of the
Yes.
numbers that came up, well, you remember it better than most of us.
Yeah,
But a couple of
the
the-
tornado was a thing.
a couple of things that kept coming up was the damage assessment, how much damage was done.
Yeah.
And some people would say 75 buildings out of 100 buildings or whatever, I don't
Yeah.
remember now, were damaged to some degree. The next thing you would get was, well, it was $82 million worth of damage. So some way there has to be an assessment for somebody to make, and I guess FEMA normally would do that, but in some way, but a quick down and dirty look at it really quickly to say, 75% of the properties in a particular area were damaged.
Yeah, a lot of my research was based around like, hey, what can I get out there quickly? What can they do quickly? This is not data that I want them to like have to process for months and months on it.
Sure.
I want the recovery to be speedy and effective.
Sure.
So yeah.
Seems like insurance companies would have some really useful data sets.
Our insurance companies love drone data.
Yeah, I'm sure they would underestimate it, defeat it.
Yes.
Yes, following up Dr. Morgan's question, so can this be used for damage assessment, like identify
say
structural
Yeah.
damages?
Again, because people are putting up roofs and they're still living there, that means that their structure is not totally destroyed. Like we saw that picture near the beginning with the two pictures of one house next to each other with the blue tarp and one completely damaged. I believe they've actually torn that building down now. There's a good way to look at, okay, well, originally, almost like a change detection. Look at where the blue tarps are and then like how it changes over time, like a temporal analysis, looking at if those blue tarps are gone later or not. That would be interesting too.
Yeah, I'm talking about the blue tarps,
Mhm.
but right after the.
Oh, like right after, yeah, yes, that would also work, yeah. To look at how many are damaged and like what the reported damage is and see how the local EMA handles it. So, yeah, that's a
How
question.
about roofing companies? Every
Oh,
one of them is gonna have a license to operate within a municipality. I mean, a permit.
Mhm.
Yeah, make a way to target them. Oh, let's go, 40 people call on one person to fix their roof.
That's all I have for y'all.
All right, thank you, Mark.
Thanks so much.
Can you hang around for